Hello guys, welcome back to ABC Trainings. Today we are going to cover topic number 10 in Creo Parametric, assembling with constraints. So as you know, Creo is used for assembly also, means basically for part modeling, surface modeling, for sheet metals, and mainly for assembly also. So how we do the assembly? By using constraints. Let's see this. To create constraints using the shortcut menu, select all of the entities to which you want to apply a single constraint. Right click and choose a constraint from the list. The constraint is created. To create constraints using constraint tools, select a constraint to apply. The select dialog box opens. Select one or more entities to constrain. When you have selected enough entities to define the constraint is applied. Now, first of all, let's understand the assembly theory. Assembling components with constraints is one of the primary methods used to create Creo parametric assemblies. After you create and name the new assembly, you can begin adding parts to the assembly. Similar to part models having design intent, assemblies also have content design intent. See, this is how actually we make the assemblies in Creo. Simple assemblies, complex assemblies, whatever you can do. This is the procedure, means how to create new assembly models. Containers can be used to store parts, assemblies, and associated tools such as workplanes and workplane sets. So now this is the proper procedure, means how to go to assembly and how to do that. We will see that in Creo. Creating new assembly models. See, this is the file. Optional. Now, in native and FEM mode structure, you can apply constraints in your own model. While defining constraints for a structure model, your goal is to fix portions of the model geometry so that the model cannot move or can move only in a predetermined way. Your model's constraints along with its loads provide the software with the real world conditions that it uses as the basis for analysis. In constraining a structure model, you are defining the extent to which your model can move in reference to a coordinate system. Thus, when you add constraints, you specify translational or rotational part movement, obviously. The software assumes that any unconstrained portion of your structure model is free to move in all of the directions, right? Use constraints for the following. Simulate real-world mounting. For example, you can constrain the radial and axial direction at a bolt hole to allow rotation about the hole. This requires a cylindrical coordinate system with the z-axis aligned with the hose axis. Enforced displacement. For example, you can move a part by a specified distance into another in a contact analysis. Presence of spring to round elements. Before applying constraints, see the guidelines for structure constraints. Every constraint is created as a part of a constraint set. In structure, you can use only one of the constraint set per analysis. Although you can combine multiple constraints into a single constraint set that is active during the analysis, you can choose from the following constraint types. Displacement constraint, create various entity-based constraint types. Then planar, pin and wall constraints, create a constraint along with planar, cylindrical or spherical surface for 3D models. Symmetry constraint, create cyclic or mirror symmetry constraints that allow you to take advantage of your model's geometric symmetry. This command is not available in FEM model. For each of these three constraint types, you need to consider different factors and use different creation methods. To review information and that is common to all three constraint types, see adding constraints. Constraint loads and analysis types. Creo simulator applies the constraint you specify to all the entities that you select and places a constraint icon at each location. For complex solid parts in assemblies, Creo Simulate automatically adds a constraint between intersecting mid surfaces whenever possible. When Creo Simulate adds such a constraint, the constraint mid surfaces are forced to deform together during a run. After you create the constraint, you can troubleshoot constraints, control constraint icon visibility, and place constraint on layers. Now see, this is the procedure to add constraints. It's open. Okay. Now exporting assemblies. I hope you guys know what is exporting the assembly means, because actually in the exploded view we can actually see means how the part moves, how the part joins or assembles with another part, and how it forms the all over the structure of the assembly. So it's actually a very important tool for exporting the assemblies. This is the step to exporting assembly. We will see that in Creo. Okay. So yeah, that's about it. We need to understand means what are the constraints, where are they, and how to make the assembly. So let's go to Creo. Alright guys, now we are in Creo. So we'll be seeing the assembly, and actually we are going to do assembly of a very simple part, just two extra parts, very simple actually, to make you understand the concept of assembly and constraints. So first of all, let's talk about constraints. Basically, constraints are like a specific geometric condition which we apply in between two parts. So whatever constraint we have given, or whatever geometric condition that we are given, those two parts are attached or in relation with each other in a parametric way according to the constraint that we have given. Got it? So let's go to new, but this time we will be not selecting the part. See, this time we will be selecting the assembly. Click on assembly. See, the file name also changes. ASM for assembly shortcut, like part there was PRT. Click on OK. See, this is the interface for assembly, plain also. Now I have made two parts already, which I will be importing in this. So click on assemble. Now see, it has opened my folder, new folder, part 1 and part 2. Only two parts I have designed, and very simple to make you understand. So let's import first of all part 1. See, component placement, it's asking me. From here only we give the constraints to it. Okay, this is a very simple part. Okay, I have made this whole. Click on OK. Right now there is no geometric condition, so just click on OK. Now again import part 2. Click on OK. Now see, let's hide the planes first. Select all, hide. Okay, now you can see it. See, so what is the constraint actually? See, now I am going to place this circular extruder part into this hole. That is meant by constraint. That type of constraint I'm going to give, that this surface, outer surface of this, should be attached to inner surface of this hole. That is the constraint. So now see, assembly part 2, click on this, and I could have given, when I imported that time also I could have given the condition, but to guys make you understand. See, edit definition, then this component placement opens. Okay, so in this, go to placement. See, constraint enabled, constraint type, it's fixed right now. So let's change it, constraint type. Okay, now wait a sec. See, new constraint I have clicked, constraint type automatic, unclick it, and let's make it, actually we can make coincident also. Okay, this type of constraints that we can give actually. Okay, so now just let's make it coincident. Select component type term, this surface, and select assembly item to this inner surface. See, I have extruded the first part to 200 mm, and this part I have extruded to 20 mm, so that you can write, actually you guys can see. See, we are given the constraint type, these two parts we have set. Just click on OK. See, we have assembled these two. So let, again I'm going to explain this. Assemble, let's bring in the part 1 first. Click on OK. See, the part is here. Let's give any kind of constraint to these two. Okay, now this part 1, area definition, component placement, suppose actually position also we can give. Click on this. Now select component item, click on this, select assembly item, this, and click on OK. See, now these two blocks I have attached it, I have made it coincident. So these are the type of constraints that you can use. You have seen the types of constraints. Okay, We have actually gone through theory also, and you guys have seen the by very simple geometry actually, that so that you can understand the concept of assembly and also constraints. Assembly is actually kind of simple instead of part modeling. Part modeling is quite difficult. Not that difficult, but as compared between two of them, assembly is very simple actually. You just need to give right constraints to right parts so that you can make the final product. Okay. Okay, now we are going to see the remaining part of this session, that is the exploded view. So let's go to new, go to assembly, click on OK, then assemble. Let's import these two parts here. This part, placement is okay, no issue. Then this part, click OK. You can directly give the constraint to this by selecting this surface. Automatic, no, that's why it automatically selects the constraint and make it this surface. See, coincident, it has managed to assemble these two parts. Click on OK. Now for exploded view, you can see here, but first of all we need to give the exploded version for this. So just click on manage views. Here explode is here, right? In this, click on edit position. Now click on this. We need to manage the position of that, only that, no. So click on this x-axis. In which direction you want to explode the surface? X-axis, and withdraw this from here to here. Whatever position you have given, whatever position you have changed, just make it okay. See, we have given the position, then close. Now see, automatically it's showing us the exploded view checked. Uncheck it. Now we have given the exploded view command to here. We have, from manage views, we have edited the position. So whenever you are going to click the exploded view, it will show that how the assembly was managed, how it was made. So this is all about the exploded view. Hope you understand this session. Let's meet in next session. Thank you.